All right, this is Mr. Ryan, and I'm going to briefly go over the intermediate value theorem. Now, one of the reasons I say briefly is I probably could spend an hour just on the intermediate value theorem. I have found that there are some people that seem to understand this theorem. It is very logical. It's just very simple, logical concept. And then there are people who struggle with it. If you are someone who understands this theorem very quickly, good for you. If you are somebody who does not understand this theorem after going over it, I recommend that you watch about 15 or 20 different videos until it finally sinks in. But the first thing that you need to understand about the intermediate value theorem is this, is even though math teachers oftentimes come up with lots of problems to try and test a student's knowledge on the intermediate value theorem, the truth is that it's very, very difficult to actually test your knowledge of the intermediate value theorem. The intermediate value theorem, very simply, is what is called an existence theorem. The intermediate value theorem basically just shows you that a number exists. It doesn't matter what that number is. The purpose of the theorem is not to find the number. The purpose of the theorem is not to find out whether the theorem is applicable. And these are all the things that a lot of math teachers do to test students' knowledge of the intermediate value theorem. In fact, in my class, I typically just try to determine whether students know whether they can apply the intermediate value theorem, what f of a would be, what f of b would be, whether k is between those two numbers. But even with all those questions that I ask my students, none of those questions really tests whether a person understands the intermediate value theorem. Okay? It is what it is. It's just an important piece of logic from the math world. Okay? So let's go ahead and read the intermediate value theorem. The intermediate value theorem has two prerequisites, two premises. If these two prerequisites are not applicable to the situation you're looking at, then you simply cannot apply the intermediate value theorem. Okay? The first requirement is that in order to apply the intermediate value theorem, a function, the function that you're looking at, f of x, has to be continuous on a closed interval with this a and b, those are x values. Okay, so let's say that you're given these x values. Let's say one of them is -7 and the other one is positive 14. Okay, so we would have to say that f of x is continuous on the closed interval between -7 and 14. So you can't just have an a and b. You're supposed to have numbers in there. Okay, so if f of x is continuous on a closed interval of x values, okay, so that's the first prerequisite. So if the function is continuous, and if the function is continuous everywhere, then you can apply the intermediate value theorem because you can pick any two x values and the function would be continuous on that interval. Second prerequisite, some arbitrary number which we're going to call k. So here's what you need to understand is k does not have to be any particular number. It's arbitrarily chosen by the person using the theorem. But here's what has to be necessary, is that the number that is chosen, k, whatever number that is, 47, 143, 19.72, whatever number that is, it has to be between f of a and f of b. Now, f of a and f of b, those are output values. Those are y values. When you plug a into f of x and you get an answer, that is f of a. And when you plug b into f of x and evaluate the number, the answer, that number is f of b. And so this number k has to be between f of a and f of b. Okay? If this number k, if you plug a, -7, into this function and you get, 53, and you plug b in, and you get 21. So 53 and 21, I think are the numbers I said. And k is 92. Well, k, 92, is not between 53 and 21. Therefore, you could not apply the intermediate value theorem. But let's say the number you were looking for is 30. Let's say k is 30. Then 30 is between 53 and 21, so you could apply the intermediate value theorem. Okay? So those are the two prerequisites. If both of those prerequisites are met, then we can draw a conclusion. So two premises, one conclusion. That conclusion goes like this. Then there is at least one number, c, and this c is an x value. Just like a and b are x values, this c is a number and it's an x value. There has to be at least one number, c, on the interval between a and b. See, c would be between a and b. If a was -7 and b was 14, then c would just be some number between -7 and 14. It doesn't matter what the number is. You don't have to find out what the number is. You can just say, hey, there is some number between -7 and 14. Such that what? Such that if you were to plug that number, c, into f of x, the answer, the output value, would be this number k. And so if this f of a is, if this f of a is 53, and this f of b is, let's say, what did we say, 21, and k is 30. And then we said that a was -7 and b was 14, right? Here's what we could conclude, is that somewhere between -7 and 14, there's a number that you can plug into this function, and the answer would be 30. And that number that you're plugging in to f of x is between -7 and 14. That's what the intermediate value theorem says. Here's a graphical example of what it says. Or this is an example of an application of the intermediate value theorem. Here we have a is an x value that is smaller than b. If I plug a in, and here this graph is the graph of f of x. If I plug a into f of x, the output, the y value, is f of a up here. If I were to plug b into the function, I would get this output value, which is right here. And then if I'm given some arbitrary value k, if k is between f of a and f of b, then I can follow k across and hit the function and then go down, and where that x value should be that plugs in to give me this k value, that x value is going to be between a and b. Has to be. Okay? And if I plug this x value in, I get f of c, and f of c is equal to k. Here's just a quick example of, or another sort of a real life situation that involves the intermediate value theorem. Basically, the idea is that, let's say that there's a hallway that leads from one building to another building, and there's no way to get out of the two buildings. And the only way to get to one building from the other building is by coming through that hallway. If you saw someone, a particular, let's say a coworker, and you work in these two buildings, and you see some guy, Jerry, and you saw him in the first building, and then you're in the second building, right? And then 10 minutes later, after seeing Jerry in the first building, you see Jerry in the building B. You can conclude that sometime in the last 10 minutes that Jerry walked down that hallway, because the hallway is the only way to get between the two buildings, and Jerry was in the first building and now he's in the second building. So at some point in the last 10 minutes, he must have been at every point along that hallway. Okay? This is the intermediate value theorem. I hope this helps a little bit. Do the best you can with it. If you understand it, awesome. If you don't understand it so much, I recommend you go find as many videos or as many things that talk about the intermediate value theorem until it slowly sinks in. It took me 3 videos. I had to watch 3 different videos before I really understood the intermediate value theorem. So don't stop until you understand this theorem. It's a very important mathematical theorem. Have a great day.